Hi, I'm Yuan. I'm a data science fellow at Insight, and I have been working on a consulting project helping a mobile game company, a thinking ape, to predict revenue from player actions. Kingdoms of Hackfire is a free-to-play mobile game where players build their kingdoms, train their dragons, and have battles with goblins. It has in-app purchases where players can buy ores or timer to speed up their building levels to unlock more features. Internally, users' accounts that are created within a certain period of time are grouped together, and those cohorts are put in the same environment to play with each other within this shard. Over time, 18 shards were created. The company cares about the monetization of each shard in the future. As this is a free game, there is only a small portion of paying users, and the company measures each shard health in terms of the average revenue per user. This graph shows that for different shards, their monetization differ over time, especially for those shards that has a low average revenue per user by day 60, means that they did not generate much revenue to the company. So the company is interested in predicting a shard's future monetization so that they can monitor shard performance and take early actions to those low-performing shards. So I built a random forest model that predicts the performance of a shard at week 8 from its performance at week 2. I pre-processed 1.2 million player data, and I was given three data sets. One is the shard data that contains some shard level statistics. The second data set contains user acquisition information. And the third data set is the most informative one, which contains players' in-game actions that were sampled weekly for 8 weeks. After data exploration, cleaning, and merging, I split the dataset into 8 weeks so that I can use the user's day 14 game metrics to predict their day 56 lifetime value. As my data has over 90 features which could potentially lead to overfitting and poor model performance, I applied a recursive feature elimination technique that reduced my feature from 92 to 16. Then I applied a random forest model that takes in a player's day 14 gameplay metrics and output their predicted day 56 lifetime value. I chose random forest over linear regression due to several reasons. First, random forest is robust to outliers, which in my case, those outliers are actually big spenders in the game, and they are the main revenue source. Second, random forest is flexible to many assumptions as required by linear regression, such as linearity, independence between the features, things like that. Also, random forest in fact gave me the best performance. Finally, I evaluate my model using the R-squared score and the root mean square error and further validate with a new shard data. After I applied my fine-tuned model to the whole dataset, I aggregated the lifetime value of all users to calculate the shard-level average revenue per user. As you can see from the error plot, that my model has a good fit. All the points are quite close to the diagonal line. Also, my model is able to identify those low-performing shards, and my model predicts quite well for the new data, for the new shard 112. My model results indicate that the amount spent during the first 2 weeks is the most informative to predict the future lifetime value. Additionally, I observed that the users' activities related to speed up exploration, upgrading their building levels, and speed up their research, as well as train their troops, are highly ranked predictors of the lifetime value of a user. To conclude, I delivered a fine-tuned random forest model for the client that can accurately predict the future shard monetization using early gameplay data so that low-performing shards can be identified, which saves the company community team tremendous amount of time instead of examining every shard. My model also suggests that marketing efforts should be prioritized to high-value users, and the community team should direct attention to the resources to engage users in leveling up their building, exploration, research, and the troop features. My name is Yuan. I'm a PhD candidate in public policy at George Washington University, and I got a master's degree at Ohio State University. Thank you for listening.